Alright, I promised you guys a video on the pizza crust problems, so here are the problems that would be great for the EOCT. So first, an example, find the area of the shaded region, and basically what it has is it has a sector, right? It has a sector marked out, and then it says I don't want the whole sector, I just want the part that's not inside the triangle. So the game plan, the idea is that you find the area of the sector and then you just subtract off the area of the triangle. Well, sounds easy enough. Find the area of a sector, subtract off the triangle. Well, it is easy enough depending on the triangle, okay? So there's basically three kinds. If you have right triangles, that's going to be very easy because the base and the height are both equal to the radius. Okay, equilateral triangles aren't too bad because you can use the 30, 60, 90s. What gets more complicated, if you want to call them a level 3, everything else is more challenging because you don't have the special right triangle rules you can use. You don't already have your base and your height obvious to you. So everything else is more challenging. So we're going to start easy and work our way up. So I'm going to start with a right triangle, then we're going to move to an equilateral triangle, and the last one that I'll do is something with any other measure besides 90 or 60. So here's what they're asking for. Area of the shaded region. Your game plan. Area of the whole sector minus area of the triangle. So the area of the sector, right, you're going to set that up as 90 over 360, angle over 360, times pi times r squared. So that's just 4 pi r. Then I need to figure out the area of my triangle. So that's 1/2 base times height. Well, the base is 4, the height is 4, so 1/2 4 times 4, which equals 8. Alright, so the area of the shaded region is just the area of your sector minus the area of your triangle. So the area of the shaded region is 4 pi minus 8 square centimeters, or approximately 4.57 square centimeters. That's all there is to it. Real straightforward. Area of the sector, subtract off area of a triangle. The area of the triangle is not too hard to find. Alright, so level 2. This would be the ones I would think would be most likely to see on the EOCT or other tests. So the game plan is still the same. Area of the sector, subtract off area of the triangle. So area of the sector, real quick, angle over 360 times pi times r squared. Okay, angle over 360 times basically the area of your circle. Put it in your calculator, you get 13.5 pi. So the area of the triangle is still the same. I'm still doing 1/2 base times height. Alright, since I know this is 60, since these are both radius, I know these two angles are both 60 as well, which means I know the base is 9. So I'm going to go ahead and replace the base with the number 9. What you've got to figure out though is the height of the triangle. So I drew it again over here, and the height of the triangle, right, is what you would get. See if I can refocus just a little. Okay, so I keep in mind that when I split this in half, that instead of being 60 is now 30, so this is a 30, 60, 90. To go from hypotenuse to short side, I divide by 2. To take my short side to long side, I multiply by the square root of 3. So 4.5 square roots of 3 works out to be the height of this triangle. So when I go plug it back in, I got my 1/2 base of 9, my height is 4.5 square roots of 3. So I'm going to multiply that all together, and I get 20.25 square roots of 3. So my answer is 3.5 pi minus 20.25 square roots of 3, which is approximately 7.34 centimeters square centimeters. Alright, so those two really aren't terrible, although that wasn't a lot of fun, it wasn't bad. Level 3. This is the hardest one. It takes up the entire page. Game plan hasn't changed, okay? Area of the sector minus area of the triangle. Area of the sector is easy. Area of the triangle is a little bit harder when you don't have some quick and easy shortcuts to follow. So area of the sector, same as it's been. Angle over 360 times pi times the radius squared. It works out to be 65 pi over 3, which is what we'll use when we're doing it in terms of pi, but just so that we know it works out to be about 68.07. Alright, so what makes this hard, what makes finding the area of the triangle hard, is that the angle doesn't make a special right triangle with a height that's easy to find. Okay, so the area of the triangle is still 1/2 base times height. We don't know the measure of the base or the height. Okay, So what I did first is I redrew just the triangle part. I said 180 minus 78 because that's what will go here. I know those two angles are equal because the two sides are radii. So this is an isosceles triangle. So I take the 180 minus 78, got 102. I split that 102 into two equal pieces because the angles are equal. So I get 51 degrees down here in the corner. Now I want to find the height. Well, when I draw in an altitude, all right, a line that cuts it directly in half, up and down, I have to divide that measure of 78 degrees in half. So this is now 39 degrees, 51 degrees, and a right angle. So whenever I have an angle and a hypotenuse, and I'm looking for a side, I use trig. So for this, when I want to figure out, I labeled the bottom side here x and the height of this thing y. So I want to find the base in this here. I want 1/2 base times height. So this base is going to be x plus x. So I'm going to let b equal 2x. So I have to find x so that I can do this. So to find x, I use trig. I've got cosine of 51 degrees because this is adjacent and hypotenuse. So cosine of 51 degrees equals adjacent over hypotenuse, multiply both sides by 10, and x is going to equal 10 times the cosine of 51. If I've lost you at this point, just stop and start watching this segment again. Okay? Right, so then we know that b equals 2 times x, so I'm going to take this whole thing and multiply it times 2. So in my calculator, one shot, 2 times 10 cosine 51, and it equals approximately 14.84. All right, great. So now I have the base of the thing. I also need to find the height of this triangle. So to find the height, I've got to use trig again, except this time, opposite in hypotenuse is sine. So I'm going to set it up all the same way. I don't have to multiply this number times 2 because it's not 2 of them, it's one height. So I'm going to let 6.7 be my height. 14.84 is my base. So 1/2 times 14.84 times 6.7 is approximately 49.714. So my answer, that's just the area of the triangle. So the answer now is I need to take the area of the sector, which was 65 pi over 3. I need to subtract off the area of that triangle, which is 49.714. So the area of the sector is approximately 18.36 square meters.